5.2b. That was A. I mean, you can keep writing. That's okay. Okay, that looks like 5.26, but it's not. 5.2b. Here we are. We're going to talk about end behavior. End behavior. Okay, so with these polynomials, let's think about x squared. X squared is a polynomial. What happens like on the ends of x squared? So if you look into the graph of x squared, what happens on the ends? What are they doing? Yeah, like that, right? Okay, yeah. X squared, right there. All right, what about negative x squared? Okay, it looks like that on the ends. What about x cubed? This is a hard one. Except not. It's like that. Okay, so like that. So one end goes down, one end goes up. What about negative x cubed, do you know? If this is x cubed, this is negative. Okay, so one goes up, one goes down. So we got our exercises today. All right, so these are the options. Will you open your door? These are the options. Shh, listen. These are the options for what could happen on a polynomial. On the ends, if you get really far out, it's either going to go up or down on both sides. Okay? So we're going to try to figure out how do you know that by looking at just, if I just tell you x to the 7th. What does x to the 7th do? Y'all knew about x squared and all that. That was awesome. But what about x to the 7th? What happens on the ends? It actually is the same as x cubed. Good job. Yes, yes. Have y'all talked about this before? Okay, all right. Y'all are just awesome. Okay, 4 cases. This is going to be like a chart for you people who like to know what's happening. Okay, if the degree is even and the leading coefficient is positive. Okay, the degree is even, that means the highest power of x is even, and the leading coefficient is positive. Out of the functions that we just said, x squared, negative x cubed, negative x cubed, which one is like that? X squared. And what happens on the ends of x squared? They both go up. They both go up. So I'm going to draw a little picture of x squared because, you know what, the function might not actually look exactly like x squared, but the end behavior is the same. Okay, so now we write this little statement out. It's not as bad as it sounds, so don't panic. Okay, as x approaches infinity, as x gets really big, like at 1 billion, what is the function doing? Is it going up or is it going down? It's going up. We just said that, right? So as x approaches infinity, f of x, our function, approaches infinity also. So we're thinking infinity. If we're talking about x, we're talking about to the right. Y'all right? If we're talking about y, we're talking about up. So really large numbers of x, really large numbers of y. Okay, so as x approaches infinity, the function goes up or approaches infinity. As x approaches negative infinity, the function does what? As x gets really small, like negative 1 billion, is the function going up or down?
Okay. So it's going only left side.
Yes, yeah. It's going up. Okay, so I know this is confusing, so please stick with me, and if you have questions, ask now. So we're talking about what happens on the end. So as you like zoom out almost, what does this look like? Is it going up? Is it going down? Is one going up and one going down? You all knew that they were both going up. That's the important part. Now, how do you write that out? By the way, if I'm asking you this statement like on homework, it'll have a blank here. The rest of it will be filled out for you. So all you have to figure out, is it going up or is it going down? Up would be called infinity, down would be negative infinity. So as x approaches infinity, like 1 billion, 2 billion, 3 billion, what is the function doing? Going up. It's going to infinity. As x approaches negative infinity, which will be way out here on this axis, like negative 1 billion, negative 2 billion, is the function going up or down? Also up, which we'll call infinity. Huh? Well, this is the function we're looking at. So as x approaches negative infinity, like over here, the function is going up. That little branch. Does that make sense? Okay. We'll practice this a lot, so y'all will get very good at it. Okay. The degree, if it's even, and the leading coefficient is negative. So again, out of those 4 that you just used your arms to show me, which one has a coefficient that's negative and a leading coefficient that's negative and a degree that's even? Negative x squared. What does negative x squared look like? You all are good at this, yes. Down. So, on the ends, what's happening? The function's going down. Alright, so the statement would look like, as x approaches infinity, f of x approaches what? Yeah, as x is getting really big, or as x is going to the right, the function's going down, which would be negative infinity. Huh? Yeah. And then as x approaches negative infinity, so as x is going to the left, f of x is doing what? Yeah, also down again, negative infinity. Yep. I know, it was actually pretty bad. I'm there with me. Okay, what if we have degree odd and leading coefficient positive? X cubed, right? What does x cubed look like? Yes. It's backwards, so it's kind of hard to tell what you're saying. Okay, it looks like this. From left to right, it rises. So now, what happens on the ends? Well, we have to talk about the specific ends. What happens on the left end? It's going down. What happens on the right end? It's going up. So, as x approaches infinity, as x is on the right end, what is the function doing? Going to infinity. As x approaches negative infinity, what's happening? Yes. It's approaching negative infinity. It's hard to tell that, so it's negative, sorry. Are we good? Okay, last one. The degree is odd, and the leading coefficient is negative. And which example was this? Negative x cubed, which falls from left to right. By the way, if you want to write these, this was y equals x cubed, y equals negative x cubed, y equals negative x squared, y equals x squared. Okay, so on the left end, what's happening? It's going up to infinity. On the right end, what's happening? Down to negative infinity. So as x approaches infinity, what? As x approaches infinity, the function is going down or negative infinity. As x approaches negative infinity, or to the left, the function is going up to positive infinity. Okay. Example. F of x equals 10x to the fourth. And I want to complete the statement. As x approaches infinity, f of x approaches what? And as x approaches negative infinity, f of x approaches what? Let me zoom out so we can see all of it. Okay, there's two ways to do this. The first is to use the chart and figure out what's happening. So if we did that, we need to decide, is the leading coefficient positive or negative? Positive, and is the degree even or odd? Even. So which one of these is it going to look like? X squared. And then you can think in your mind, okay, what does x squared look like? It's going up on both. The other way to do this would be to type this in the calculator, 10x to the fourth, and see what's happening. Now let me warn you about this. On some of these that we're going to get to, they're going to have little loops. So it might look like this. And if you're zoomed in too far, like if this is what you see on your screen, you may think that they're both going down, when actually they're both going up. So if you use this method where you're going to graph it and look at it, you have to be very, very careful that you can see everything that's happening on your graph, which we will learn how to do as we keep going through chapter 5, but I'm not sure that's the best approach yet. Maybe for the test that might be a good approach, but for now I would use the chart to make sure. If you want to look on your calculator and see kind of what it looks like, that's fine, but just don't be super trusting of your calculator, because you might not have the whole picture. Make sense? Okay, so 10x to the fourth looks like x squared, and we know that that's going up no matter which way x is going. They're both going up. Okay, f of x equals negative 2x cubed plus 7x minus 4. And I'm just going to write the blank. Well, no, I guess I'll write the blank. As x approaches infinity, f of x approaches what? As x approaches negative infinity, f of x approaches what? Okay, what's the leading coefficient, positive or negative? Negative. What's the degree? Odd. So negative and odd, which one is this going to look like? Negative x cubed. Okay, so in your mind, if you can picture negative x cubed, that's awesome. Another idea is, if you know it's negative x cubed, but you can't remember what it looks like, you could graph that, and you could see what's happening. Does that make sense? Okay, so negative x cubed is this one up here. As x approaches negative, or as x approaches infinity, the function's going down. As x approaches negative infinity, the function's going up. Yeah, exactly. Well, the problem is if you just write this, I don't know which direction you're talking about. Yeah. If they're both the same, then that's probably okay. But if they're different, then you have to write it out. Okay, last thing in 5.2 is graphing. So to graph, we're going to use the calculator. And specifically, we'll use the table and the graph. So these are a little bit tricky to graph because sometimes they have these little, like I was drawing on the board, they have these little things. And you have to figure out, like, where do those little things happen? So you can't just plot some points and try to connect it with a smooth curve. You have to have an idea what it looks like, and then you have to go to the table to pick some points. And the other thing you're going to do is check the end behavior. If this was the one you were graphing, and you only checked the points in here, and you thought it was going down, when you check the end behavior, you realize, wait a second, I must have missed something. It's not good. That's why we want to check it. Okay, example. equals negative x to the fourth plus 4x cubed minus x squared plus 6. So go ahead and get your calculator out and plug that in. Plus 6, yes. And I always like to check the end behavior first, actually, to make sure I have the picture on the screen. So here we have leading coefficient negative, degree even. What's that going to look like? So like negative something, negative x squared or negative x cubed, which one? Negative x squared, it's even. Negative x squared, which means they both go down. And I have that on my screen. I see where they actually both go down, so I'm good. Do you see that white on yours? Or maybe you're too zoomed in. Hit zoom 6. Zoom 6 is the standard zoom. It goes like negative 10 to 10, negative 10. Okay, then you probably answered it. I would go back. Okay, so this is what we have. Now, notice that I can't see actually how high this goes, but I know that it happens at like maybe around 2 or 3. So I'm going to go to my table, and I'm going to graph some of these points that were on my screen. So negative 1, 0 looks like a good one to graph. Negative 1, 0. 0, 6. I really should have counted by 2s. I'm going to count by 2. So negative 1, 0 would actually be here. Don't count this point. 0, 6. 1, 8. 2, 18, which I'm just going to say would be somewhere up here. 3 would be 24. And then 4 would be negative 10, somewhere down here. Because you have it on ask probably. So just type some stuff in like negative 1, 0, 1, 2. If you go to second window, it's table sets, and then change it to auto. Yeah. Is that the only one that's on ask? Yeah, it should be. If you scroll up, it'll be the negatives. Does everyone see how we did that? I want the shape. So I had to do however many points actually drew the shape. Does that make sense? So it's going to actually be different for each one. Okay. Awesome. Do you want to do one more or are you good? 10? You're good? Perfect. Alright, we have time to work on the homework, so we have to get that out.